Hello guys, this is CodeNCode and this is video editorial for the problem or even subsequence taken from Codeforces. This is problem D from div 2 round and the problem is rated 2000, which means it's a hard problem. We'll be solving this problem using binary search. Alright, so let's get started. Let's have a look at the problem statement. So the problem statement says that you are given an integer array A of size n, right? And also you are given an integer k. You have to pick a subsequence of length k out of this array. And you have to pick the subsequence in such a way that minimizes the cost of the subsequence. Now, what is the cost of the subsequence? The cost of subsequence is defined by these two. Okay, you find the maximum among all elements of odd indices and then maximum among all elements of odd indices in your subsequence of length 4, right? And then you take minimum of them. For example, let's say you picked a subsequence which is 756. This is a subsequence, right? The cost of this subsequence will be max of odd indices, which is 7 and 6. So max of 7 and 6 is clearly 7. Max of even indices element, even index element is only 5 at this point. So maximum of 5 is 5 clearly. So take minimum of these two, which is 5, right? So cost of this subsequence is 5. So you are given an integer array of size n, out of which you have to pick a subsequence of size k such that it has the minimum cost among all possible k length subsequences, right? So this will be much clearer if I explain with the help of this example. For example, you're given in integer array of length 6. First of all, in first line you'll be given n and k. So n is 6, k is 4. So out of 6 element you have to pick 4 element subsequence, right? You have to pick a subsequence, right? You can't randomly pick element. You have to pick them in the same order. Yeah, I hope you understand what is a subsequence. Just to give you an idea, subsequence in a subsequence that you choose out of this array, elements relative position should not change. For example, the 5 must always come before 50, right? You can't have a subsequence in which 50 is the first element, 5 is the second element, uh, and another 5 is the third element. That is not possible, right? So this is the problem. So let's say we pick this subsequence 5 3 52, 5 3 50 and 2. This is one of the possible 4 length subsequence, right? So odd indices elements are 5 and 50. Max of this will be 50. Even indiced elements are 3 and 2. Max of 3 and 2 will be 3. So minimum of these two will be 3. So the cost of this subsequence is 3 actually. Similarly, you can pick this subsequence 5 54 and 5, 5 54 and 5. This is another subsequence, one of the possible subsequence of length 4. So maximum of odd indiced element is 5. Maximum of even indiced element is 50, right? And minimum of these two is 5. So cost of this subsequence is 5. And similarly, another example of 4 length subsequence out of this can be 5 3 2 and 4. 5 3 2 and 4. Cost of this is 4, right? So out of all of this, you can clearly see this subsequence has least cost, which is 3. So you need to print 3. You don't have to actually print the subsequence. You only have to print what is the minimum cost, that is 3. So your output should be 3. Even though there are multiple examples, I have taken only 3 to explain you that how what the problem wants you to solve. All right, now that you have the idea, so the question is how we are going to solve it, and another question is how we'll solve this using binary search, right? Initially, if you have a look at this problem or you think about the solution of this problem, you might think that how can you actually implement binary search here, which is absolutely true. So let's make some observation as always that I give you. It's got these observations kind of hint so that you can build your solution yourself, right? So let's observe something. All right. So let's have a look at this observation. So let's say this is the input, this is the subsequence that you have chosen, and these elements are odd indiced elements, and these elements are even indiced elements, right? So this is odd sequence, this is your even sequence of your overall subsequence, right? So if any sequence, doesn't matter whether we are talking about odd sequence or even sequence, right? If any sequence, if any sequence has all the elements less than equals to d, then the overall result will be less than equals to d. What do I mean by that is, uh, no matter you pick the odd sequence or even subsequence, if all of the elements of that sequence, right, odd or even, are less than equals to certain integer, let's say d, let's say 5. If all of the even elements are less than equals to 5, then overall cost of this sequence will be less than equals to 5. right? So if let's say odd sequence, all of the elements in the odd indiced, basically all of the odd indiced elements, if all of those are less than equals to d, then the overall result will be less than equals to d, overall cost of this sequence, right? Because why is that so? See, result depends on maximum of odd indiced elements and maximum of even indiced element and minimum of those two, right? Since we know for odd indiced elements, none of the element go beyond d. That means maximum is d, right? So you can directly replace it with d. Now, for even indiced element, even though we don't know, right? Even though at this point you can actually see, but we don't know what is the elements of even indiced. Basically, what is the max of even indiced elements? Doesn't matter. The result still going to be less than equals to d. Why? See, let's say maximum of even indiced element is actually greater than d. It's let's say d plus 10 or d plus 20 or anything, any number d plus x, right? Then minimum of those two will be d itself. So if maximum of even indiced element is greater than d, the result clearly is going to be d, right? But what if the maximum of even indiced element is actually less than d? Let's say d minus 1, yeah, d minus 5, right? In that case, here you will have d minus 5. Overall result will be d minus 5, which is again true. Result is less than equals to d, right? So no matter what, if you can prove that any sequence, be it odd or even, elements of all of that sequence, all of the elements are less than equals to d, then the overall result is going to be less than equals to d. If I can prove that for my sequence, all of the even elements, right, all of the elements at even indices are less than equals to 50, then my overall result is going to be less than equals to 50. The overall result means the cost of that subsequence, right, is going to be less than equals to 50. I don't have to go through the whole subsequence. Now this observation is enough to give you a solution using binary search. Okay, just try to think in terms of finding the solution using binary search. So on which thing you are going to apply binary search? You will be applying uh, binary search on the result. Your result will be in the range 1 to 100. Can 50 be the result, right? If 50 is the result, then the cost of the subsequence should be less than equals to 50, right? So using this fact, you can actually apply binary search. How? Let me show you that also. First of all, we know that if any sequence order even is less than equals to d, then result is going to be less than equals to d, right? So one thing for you, I'll explain these two in a moment. One thing for you, let's say n is equals to 6, k is equals to 4, and this is your input array. What is the maximum value of result can be, right? What is the maximum value of result can be? Just think about it, pause the video. So if you think about it, the maximum value of result can be the maximum element of the input array. Why? See, because the cost of the subsequence that you will be picking depends on the input array, right? If input array, so of course, there can be test cases in which the maximum element of the input array is your overall result. For example, if I give you an input in such a way that all of the elements are 50, 50, 50, 50, 50, right? So no matter which subsequence you choose, your result is going to be 50, which is the max element, right? So your maximum result can be the maximum element of the input array, right, which is 50. So how we are going to apply binary search is this. We'll have LR that represents our range, that our result is in this range. Lowest can be 1, maximum can be the maximum element of the input array, which is 50 in this case. So I have taken result to be 50, the maximum. Now I'll initialize result to be worst. We have to minimize it, so I'll initialize it with the worst, which is 50. Now we'll apply binary search. How do you do that? See, you know the result will be in this range, so find the mid of it, which is 25. So now, can 25 be the answer? See, 25 can be the answer if either odd elements, all of the odd elements of fourth line subsequence are less than equals to 25, or all of the even element of four line subsequence is less than equals to 25. All right, because we know either odd or even, if any of the sequence is less than equals to 25, the overall result will be less than equals to 25. So if I can find any subsequence of length 4 in which odd, yeah, all of the odd elements or all of the even elements are less than equals to 25, then the result is going to be less than equals to 25, right? Now, that is exactly where these two functions help. Is possible odd will tell you whether in this array of length n, you can find a subsequence of length k such that all odd elements are less than equals to d, right? So if I can find a subsequence of, of length k where all odd elements are less than equals to d, that means the overall result is going to be less than equals to d, right? Don't worry about this function, we will build this function. Just assume that you already have this function. And what is the purpose of this function? This will tell you whether you can find a subsequence of length k in which all odd elements are less than equals to d or no. It will return true or false based on that. Similarly, this will check for even places, right? Using these two functions, you can actually check whether an odd or even subsequence exists where all of the elements are less than equals to d or not. If all of the elements are less than equals to d, the overall result will be less than equals to d, right? Now I'll be checking whether result can be 25 or not. So what I'll do, I'll call is possible odd and is possible even. If any of this is true for 25, my d will be 25, right? Then yes, result is possible. Don't worry, we will build these two functions, right? So what we'll do, we'll check for 25. So if you see, even if you pick first four elements, right, all of the even elements, since we have to pick a subsequence of length 4, that's why I'm picking first four elements. All of the even indiced elements are less than equal to 25. That means yes, I can pick a subsequence of length 4 in which all even elements are less than equals to 25. If all even elements are less than equals to 25, that means the overall result will be less than equals to 25. That means yes, my result will be less than equals to 25. So I can update the result to be 25. Now, since I've updated the result to be 25, you will, since I know the result is less than equals to 25, I don't have to check for 26, 27, 28, 29, dash, dash, dash till 50, right? I don't have to check them because I'm minimizing the result. So I won't check for those. That's why my R will be updated. My range will be reduced, right? And new range will be R is equals to mid minus 1, which is 25 minus 1, 24. This is my new range. I have to search in range 1 to 24. Again, same thing will happen. Uh, New mid will be 12, right? So again, you'll check whether any odd or even subsequence exists such that all of its elements are less than equals to 12, right? So if you again pick, you all you have to do is call these two function in actual implementation. I'm just giving you an idea. If you see, even if you pick the first four element as your subsequence, again, all even elements are less than equals to 12. If all if one sequence is less than equals to 12, that means the overall result will be less than equals to 12. That means I can reduce my result to 12. And again, R will be updated to mid minus 1, which is 12 minus 1, 11. Again, new mid will be 6, right? 11 plus 1, 12. 12 divided by 2 is 6. So you will again check, you will again call these two functions and check whether there exists a subsequence of length 4 such that all odd or even elements are less than equals to 6. So again, if you pick first four elements, all even elements are less than equals to 6. So that is true. When it is true, I'll again update my result to 6 and R to 5. And new mid will be 3. I'll check for 3. And again, this will be true. So result will be updated to 3. R will be updated to mid minus 1, which is 3 minus 1, 2. Now the new mid will be 1. So, can you find any subsequence of length 4 in which all odd or all even elements are less than equals to 1? The answer is no, because the minimum element is 2. So, no matter which subsequence you will choose, the all of the elements will be at least 2. So, 1 is not possible at all. So, these two functions will return false. They will return false. That means the result cannot be minimized. So, we have to update our L. So L is equals to mid plus 1. Mid was 1. 1 plus 1 will 2. Right? So why we updated L? Because see, the result cannot be less than or equals to 1. So we have to look upward. Right? So above 1. Above 1 is above mid. Above mid will be mid plus 1. So L will be updated to mid plus 1. Now again, if you'll L and R are same, if you'll check for this, it will again return false. And again, when it returns false, L will be updated to mid plus 1. Mid plus 1 will be 3. L becomes 3, R becomes 2, your while loop will stop. When you're running a binary search, you have a while loop where L is less than equals to R. When L becomes greater than R, you stop. And when you stop, you have the result 3, which is the actual result of this. है ना? So this way, you will get the result. So see, just by using this fact, right, we are able to find the overall result using binary search. Now the question arises, how do you implement this? How do I check that in the input array of size n, I can find a subsequence of length k such that all of the elements are less than equals to t. All of the odd or all of the even elements are less than equals to t. So let's build this one. Is possible odd. What are we building? Is possible even. So let's build this one. All right. So let me tell you how do you actually implement these two. Okay. So let me show you that. Now before I show you that, let me just show you the code. Okay. Just to give you a perspective. So see, we are reading n and k, after which we are reading n integers, right? And then I'm calling binary search. L is equals to 1. What is the minimum result? 1. What is the possible minimum value of result? That is maximum of input, right? Instead of taking that, I know all of the integers will be less than equals to 10 to the power 9 as given in the problem statement. So I'm directly passing 10 to the power 9 in the worst case. It doesn't matter, you will get your result. Now, here is the binary search. What you do, you initialize your result with the maximum value, which is h, and after that you run a while loop, the standard thing that you do in binary search. Then you calculate mid, and what are you doing? You're checking if it is possible to form a subsequence in which all odd or all even length elements are less than equals to mid. Now you might think that where are n and k, right? I haven't passed n and k because I have defined those globally. So my is possible function can directly access n and can directly access k. All right. So that's why in my is possible function you don't see there. The important thing is that all you have to do is call the is possible even and is possible odd function. If any of these two returns true, that means you have found a subsequence whose either all odd elements or all even elements are less than equals to mid. That means you can update your result answer to mid, right? And then your h will be updated to mid minus 1. Otherwise, L will be updated to mid plus 1, right? Standard binary search thing. Now the only thing that remains is to implement this is possible even and is possible odd function. And to implement this is very easy. Let me just show you here. All right. So let's get started. So see here, what is possible even, what will it check? It will check in this array. This is the input array of length n, right? Is there any subsequence of length k such that all even indiced element are less than equals to d, right? D in this case I'm taking 3 as an example. All right. So to implement this, all you need is a counter. If you see here, sum. This is the only thing that you need. Sum, I've implemented using sum. You can call it count, right? It counts how many elements I have found in a valid subsequence. A valid subsequence will be, since we are calling even function, so for this a valid subsequence is that at all even indices value should be less than equals to t. That is valid subsequence. All right. So initially, how many elements have I found in my valid subsequence? 0. All right. So now we are running a for loop to all of these elements of this input array, right? So now I'm at this index. Since counter is equals to 0, that means this is going to be my first element, right? First element of my subsequence that I'm going to choose of length 4. So this is going, since counter is 0, this is going to be the first element. This is going to be first element. I'm looking for even subsequence. That means I don't care what element is there at odd indices, right? This function only tells it returns true if all elements at even indices, right? If all element at even indices are less than equals to t. That means what element is there at odd indice, we don't care. So since counter is equals to 0, that means this will be the first element, and hence I don't care. One first element, that means odd indiced element. So I don't care what element this is, right? So I can directly increment my counter and I'll add it to my subsequence. That means this element is part of my 4 length subsequence, right? Now I plus plus, I'm here again. Counter is equals to odd. That means the new element will be the even indexed element. That means now since this is at even index, I must enforce this rule. That means this element must be less than equals to t, right? Because this is at even index, right? In my subsequence, this is first element of my subsequence. This might be second element. So what defines that? If this is less than equals to 3, which is true, so this can be my second element, right? So counter will be incremented, counter will become 2. And this is green, that means these two are two elements of my subsequence, all right? Now again, this is just for visual representation. Only your counter will be there to tell you that how many elements are there. All right. Now, I plus plus we are here, and since counter is equals to even, that means this element is going to be odd. Since this is going to be odd, we don't care what element this is. So directly increment counter and add this element to your subsequence. Right. Counter is 3. That means you have found 3-length subsequence where all elements at even indices are less than equals to t. Right. Now I plus plus we are here. Since counter is odd, that means this will be your even element, right? Even indiced element. So that means we need to enforce this rule. Is 7 less than equals to 3? Answer is no. Since this is not true, we won't add it here. We won't add this element into our subsequence, and hence counter won't increment. Directly I plus plus. My bad. I plus plus, we have less this element, right? Now we are here. Now since counter is equals to 3, that means till now we have only found 3 elements in our subsequence. Since counter is equals to 3, this will be my fourth element, that means even indiced element. This must be less than equals to 3. Since this is less than equals to 3, this will be added in my subsequence counter plus plus. Again, since a counter is 4, this element will be fifth element. Since this is odd indiced element, we don't care, right? Since counter is equals to 4, this will be fifth element in my subsequence. Fifth element means odd index, and since we are looking for even indiced element, we don't care what element here is. We can directly increment the counter. Now we are out of the basically our for loop runs out. We come out of the for loop and we check what is the length of counter. Counter is equals to 5. That means I have found a subsequence of length 5 where all of the elements at even indices are less than equals to t. Right? So should I return true or false? We had to find a subsequence of length 4, but we have found a length 5 subsequence. Right? Should I return true or not? Answer is yes, you should return true. Why? Because you have found a 5 length subsequence which is valid. You only needed 4. What you'll do? Just remove the last element. Okay, you have already found a 4 length. So if count is greater than or equal to k, you can return true, otherwise return false. Right? So if you see here, this is exactly what we are doing. For is possible even, sum initialized to 0, sum is counter. We are going through all of the elements of the input array. So if sum modulo 2 is equals to 0, that means till now we have even number of elements. That means the new element will be at odd place, and since we are looking for even elements and the new element will be at odd place, we don't care, we directly increment the sum. If that is not the case, that means the new element is not at the odd place but at the even place. Now that means you are in the else condition. Now you will only increment if and only if the new element is less than equals to the value, the d. This is d. All right. So if it is less than equals to d, sum plus plus. And finally, once you come out of this for loop, if sum is greater than equals to k, return true. So this statement return true when sum is greater than equals to k, otherwise false. Similarly, you can form is possible odd. I am leaving this as an exercise for you. All right. So build this. So now, if we see the solution, all we are doing is reading n and k, reading n integers, and then calling binary search function, right? With minimum result can be 1, maximum result can be 10 to the power 9. This is 10 to the power 9. 1 in 9 means 10 to the power 9. Why? Because in the constant in the problem statement, it is said that maximum value of ai can be 10 to the power 9. That's why I've said 10 to the power 9. And then you are running the binary search. If is possible odd or even, at mid returns true. If any of these two return true, that means you have found a subsequence using which you can minimize the result till mid. That's why I update the result till mid, update h to mid minus 1. Otherwise, if that is not possible, you need to look upward. So L will be updated to mid plus 1. So yeah, this is how you solve this problem rated 2000. All right, so this is how you solve this problem. So yeah, this is it for this lecture. If you find any interesting problem that we should solve in the future, you can always suggest me in the comment section. So this is all for this lecture, and hopefully you are able to solve this problem. All right, so yeah, this is it for this lecture. Let's meet again in the next lecture. Until the next video drops, keep coding. Thank you.